The potential of data science and machine learning is almost infinite, as we're probably starting to see in this event. But getting started can be overwhelming. In the next workshop, Michal Hucko from Canonical will demonstrate how you can quickly set up an environment in Ubuntu with Canonical's data science stack.
Hi everyone, my name is Michal and welcome to my session today where I will be talking about the tool which is called Data Science Stack. I am a machine learning DevOps engineer here at Canonical and I'm working on projects like CharmCubeflow, MLflow and Data Science Stack. So let's start with what is actually the Data Science Stack. So Data Science Stack is a ready-to-run environment for machine learning developers. It's a CLI for managing the containerized ML environments and images like PyTorch and TensorFlow. And the best part is that it's built on top of open source technology because that's the technology which we like here. It supports running on different kinds of GPUs by providers like vendors like NVIDIA or Intel, for example, which is very interesting. When I was starting with machine learning at university a lot of years ago, I was having always problems with the setup of environment. I think you are struggling with the same problem. Like, it's one thing to install a Jupyter Notebook in an environment when you want to use CPU, but it's another thing when you need to use GPUs, you want to have the optimized environment, you need all the good drivers, and all the tutorials on the internet are obsolete, and you don't really know what to do, right? And then you just give up and you say, okay, ML is not for me. Data Science Stack is solving this problem, and many other problems, of course. So the problem with the GPUs and with drivers is solved for you, right? You just need to run a couple of commands and then the environment for your development and experimenting with machine learning is ready to use. So that's the Data Science Stack, and that's one of the main goals and main objectives of it. There are a lot of other benefits. It's a fully open source solution, right? So you can find a repository online, you can drop an issue or leave a comment, and we will try to improve it in the future. It's built with the developer in mind, right? So because we are machine learning engineers, we know what are the daily struggles. So you can develop your machine learning workflows in your local computer in the Data Science Stack. You can version them with MLflow, which is a tool running inside the Data Science Stack, and you don't need to worry about anything, right? One vendor for a whole ML lifecycle is another great benefit of it. Because you can just use the capabilities of the Data Science Stack to run workflows on top of, let's say, NVIDIA and also Intel. It runs anywhere on desktop, cloud, at the edge. It's a snap, so you need to have an environment which supports installing snaps because we are using the advantages of snaps as it's self-contained and it's secure. So that's another great advantage of Data Science Stack. And it's connected with silicon partners, right? So we are developing this also with the graphics card vendors, as I was saying. And it's a native to Ubuntu, but it's running also outside of Ubuntu, right? So this is the architecture of Data Science Stack, but before I go to the architecture of Data Science Stack, let's go first through the installation, because we need to wait for some things to run behind the scenes, because this is a live demo, and most of this demo I will be actually showing you something rather than just reading the slides. So for the rest of this guide or this tutorial or session, I will be using this documentation page, which is the Data Science Stack official documentation. If you go to the browser of your choice or the search engine of your choice and you put the Data Science Stack documentation, you will end up here. And in the tutorial section, in the Get Started section, this is the part where we will be actually running things, okay? And I will go back to this architectural overview, and as you can see, Data Science Stack is running on top of your OS, and it expects you to have a Kubernetes deployment running inside your computer. For the purpose of this demonstration, or Data Science Stack is also tested with microK8s. microK8s is another great snap developed by Canonical, which allows you to run a small Kubernetes cluster in your computer, and we will be using microK8s for this demo session. So if you want to install microK8s, you can run command sudo snap install microK8s, and I will be using version 1.28 stable for now, and we will be enabling these add-ons. These add-ons are just giving you the functionality, advanced functionality of the Kubernetes cluster in your computer, and we need the host path storage because that's the kind of storage class which we are using behind the scenes. If you have decided you want to run Data Science Stack with a different Kubernetes deployment, then you need to make sure that the host path storage class is enabled. So this is how you can do it with microK8s, and because I know this takes time, like a couple of minutes, I decided to pre-install it. That's why we see it's just right now successful within a couple of seconds. The next add-on for the purpose of this demonstration we need is the add-on for GPUs, because our demonstration today, I will show you how you can run machine learning workflows using your GPUs, and this computer, my desktop, is running with the GPU inside, NVIDIA GPU. So if you want to enable NVIDIA GPUs in your Kubernetes cluster, you can run microcades. You can run this command sudo microcades enable GPU. So this will install the GPU add-on inside your microcades Kubernetes cluster. And the next thing what we need is we need to install sudo snap install data science stack. Oh yeah, install data science stack. Right now, there is the latest stable channel. If you go to the Snap store, you can find there also Edge channel, which is for development purposes, but we are installing stable. The next thing what we need to do is we need to tell data science stack to connect to microcades. That's the last third command, which is connecting the Kubernetes cluster and the data science stack. As you can see, for the rest of this tutorial, I will be using DSS CLI, and DSS initialize command is the command which we need to use to connect data science stack to Kubernetes. Here we need to provide a kubeconfig. I like to call kubeconfig a key to your Kubernetes cluster. So we are saying the key to our Kubernetes cluster is the key from microcades. You can get the microcades kubeconfig by running command microcades kubeconfig. So it's the same way as you are setting, for example, kubectl, you need to provide the kubeconfig. So the same way is with the DSS, you need to provide kubeconfig. And this will now initialize the data science stack, and it can take a couple of minutes because it needs to download all the images. So the speed of this deployment really depends on your internet connection, and mine is not the best every time. So what is the architecture? As we were saying, behind the scenes, the data science stack is expecting you to have the microcades. And we expect you to have enabled the operator, GPU operator for the vendor which you want to use for your machine learning workflows. In this case, it was NVIDIA, and I have enabled it with the command sudo microcades enable GPU. If you are interested in how you can enable other things, you should always go to our data science stack documentation, and in the how to guide section, we have enabled GPUs sections, subsections, and for each vendor, we have a step-by-step guide how you can do it with microcades, okay? Or other Kubernetes providers. So always go there and check out what is written there if you are hesitant. So with this, you have the local Kubernetes cluster deployed with all the necessary operators for running the GPU workflows. Then the data science stack itself consists of two main parts. First is the MLflow, and then the other parts are the notebooks, data science stack notebooks. Those notebooks, I will call them notebooks, but in reality, those are Jupyter Labs servers where you can create notebooks, but we call them notebooks. Allows you to create or to run machine learning workflows based on Python from inside there. These notebooks are running images, and I will show you, we provide a couple of recommendations for images which you can use, but you can provide your own image. And with these images, you can run the ML frameworks inside, for example, like PyTorch and TensorFlow, to actually run your machine learning workflows with, right? These images have also all the necessary drivers pre-installed, so you don't need to worry about those. And these two components are the key parts of data science stack. Because you are running MLflow, the whole setup of MLflow for your notebooks is handled for you, so you don't need to worry about it. So by default, you can just start logging models inside, and the MLflow is connected to every notebook inside your data science stack deployment. So I will run a small demo right now where we deploy the data science stack on top of microcades. That's something what we are already doing behind the scenes. Then we will create an NVIDIA GPU-based TensorFlow notebook where we will be running small training session, which we will later store in our MLflow running inside our data science stack. Later, we will create a second notebook from inside which we will load the model which was stored in MLflow from the first notebook, and then we will run a small inference. All the code from this session can be found on my GitHub. You can find me also on social media. You can reach out to me if you have some problems. It's Michal on GitHub /data science stack examples. You can clone it. I will be using the demo here. It's the repository from here. That's what we are using. So going back to our data science stack, you can see that DSS is initialized and you are ready to create notebooks. Right now, I will just create a notebook because it takes some time to create the TensorFlow CUDA-based notebook. For those of you who know some machine learning workflows GPU, they know that the image is quite big, so we will need to wait. So it's DSS create, and we are creating a notebook called TensorFlow CUDA notebook with the image TensorFlow CUDA. And while this is running, I will be explaining you some stuff on another card of my terminal. So the DSS CLI comes with a couple of commands which help you to manage notebooks inside your cluster. You can always reach out to help. And we put a lot of effort to make this as UX friendly as possible. There is a create command which we are running right now. And if we check the create command, we will see that it comes with a couple of recommended images. Okay, so if you want to create a notebook, you need to provide the notebook name and then the image parameter where you provide an image which you want to run. You don't need to provide the whole path to the image if you are using recommended images, as I was doing here, right? As you can see, the command which I ran was image -- TensorFlow CUDA, right? But behind the scenes, the TensorFlow CUDA is referring to this Jupyter TensorFlow CUDA full version 1.80, right? You can check out that Docker Hub, and there are also other versions if you want a particular version of a TensorFlow, right? So as you can see, we are providing recommended images for TensorFlow for CPU, PyTorch for CPU, and then PyTorch CUDA-based image, which is the image used for NVIDIA workflows, the TensorFlow CUDA-based image, which is also used for those workflows. And then we also provide recommended images for Intel-based workflows or environment where you have actually the Intel enabled. Okay, how do I know what is enabled in my data science stack? That's a good question. You can achieve this by running command DSS status. DSS status will provide you the current status of the data science stack. As you can see, the MLflow deployment is ready. You can see the URL where the MLflow is located. That's the URL which I will connect right now. But then you can see also if the acceleration for different GPU vendors are enabled. You can have both acceleration enabled at the same time, so you can create NVIDIA GPU-based notebooks and Intel GPU-based notebooks at the same time. As of right now, on my Kubernetes cluster, I have only enabled the GPU acceleration for my NVIDIA graphics card, which is RTX 3070 Ti. The Intel GPU acceleration is disabled right now. So now I click on the MLflow link, and this is the MLflow UI, where all the experiments will be listed later when we will be running a small example of training process and later the prediction. That's the experiment. Experiment is an object in MLflow which helps you to play around with your models, right? So you can say, this is a model and I'm running a couple of experiments with it. And as soon as you find the right parameter, because with models you want to optimize parameters and you want to optimize data and stuff like this, then you can decide which model can go to staging or production. So that's the models. If you're interested more into details of MLflow, this session is not about explaining how MLflow works. You can check out the upstream documentation for the MLflow. I highly recommend it. It's a very interesting tool. As I said, we are using just one capability of MLflow, which is the model registry capability, which means that you can version your models, you can play around with your models with experiments and stuff like this, okay? So that's the MLflow part. And as you can see, right now, my TensorFlow CUDA notebook was deployed because it's a success. Notebook was deployed. So if you, for some reason, lost this access to notebook, you can every time run command DSS list, which lists you all available notebooks in your data science stack deployment. As you can see right now, I have just one, which is this TensorFlow CUDA notebook. For the purpose of this demonstration, I will also create a second notebook from which I will run later the inference. So let's see. Create, TensorFlow CUDA, and let's call it TensorFlow CUDA Notebook 2. And while this one is creating, I will be doing stuff in the first notebook. So you can connect to the notebook through this URL. And this is the Jupyter UI, Jupyter Lab UI. Jupyter Lab is a tool for creating Jupyter notebooks. And as you can see, it's interesting that there was a shared folder pre-mounted in this notebook. We never created it. This shared folder is shared across all the notebooks inside the Jupyter Lab servers inside your data science stack. So now I'm creating a second notebook, right? It was already created, so DSS list. And as you can see, I have two notebooks right now with two different URLs I can connect. But everything I put inside this shared folder will be shared with the second notebook and all the notebooks inside my DSS deployment. Whatever I put outside of the shared folder will not be shared, okay? So I go to shared, and the thing what I need to do is I need to actually run some workflow with the NVIDIA graphics card, right? So how can I do it? I have created an example with running some prediction on the NIST dataset. It's not really important for the purpose of this video. What is NIST? You can Google it. but it's a very simple it's a very simple data set on top of which we are running a neural network. So how to do it? You can get the HTTPS URL of this repository, and then you can go back to your Jupyter lab. I'm inside the shared folder, and if you click on this command, on this button, it says git clone. You can provide an URL from which the git should be cloned directly inside your notebook. It has created the data science stack folder with all the data from the repository, and I will open the train model. Sorry. Yeah. These notebooks don't come with MLflow library pre-install. So first thing what I need to do is I need to actually install the MLflow, which I can do with this command. Now this will install the MLflow library for me. And in the next steps now, I will use TensorFlow to run some simple computations, okay? So first I'm importing some libraries which are needed for this one. And then this cell will tell me if I'm really using GPUs or am I still using CPU. So TensorFlow has this config where you can list the devices it recognized, and if it has recognized some GPU devices, under the devices GPU there should be a record there should be a number which should be greater than 0 in this case. So I expect this command to output using GPU. Let's see. As you can see, it's using GPU. Don't worry about this. These are just warnings. And now this is the heart of the example which I will be running right now. So because I'm connected to MLflow. I don't see I'm connected to MLflow, but I am actually. If I print environment, right? Sorry. If I print environment and if I grab MLflow, you can see that the connection strings needed for MLflow are set up for me, and the MLflow tracking URL is pointing to some. So this is the environment variable which you need to have set up if you want to connect to MLflow. So I can now create an autolog session inside my cell, and then I can create an experiment inside my MLflow. Okay, again, this is not a tutorial about MLflow, just showing you what you can do. Next, I'm importing a Keras MNIST dataset, which is a very simple dataset for recognizing numbers. I am normalizing the dataset, and then here I'm creating a simple sequential model with a couple of dense hidden layers and a dropout layer. And then I'm I'm compiling the model with the Adam optimizer, and then I will run an MLflow session where I will fit the model. Okay, inside this MLflow session, what I want to do, I want to record the test loss and test accuracy on the test data. Okay, and then I want to also record the final model inside the MLflow. Okay, and I want to log it as a model, not just as experiment. I'm just showing you. So if you create the experiment and you start autolog and you start the session, everything will be recorded in the experiment, but I also want to show you how you can create the actual model with this command. So you need to provide the model name and then create the model with the command log model. And then at the end, I want to end the session, and then I am just printing out the model name. So if I run this, right, there are a lot of interesting stuff happening, but as you can see, there is an output saying that I'm trying to use the GPU things, and then here are the epochs. I'm running 5 epochs where I'm training on the whole dataset. And as you can see, based on this one, I'm using GPU because the device was recognized. And now after the 5th epoch, you can see everything is training, the loss and accuracy is changing, and then I'm saying that I'm trying to, I have wrote the model into the MLflow. So now if I go to the MLflow, yeah, the model was written. If I go to the experiments, I refresh, there has been an experiment created for me. The name is auto-generated, but I can see that the experiment was created. There are some parameters logged with it, like batch size, class weight, yeah. So you can see the model is now inside the MLflow. With these experiments, I can track what parameters I was using for this run and what was the metrics log for these parameters. So for example, for this set of parameters, the accuracy was 0.977, loss was like this. And then what I have done also with the log model, in the models section, there is the NIST TensorFlow model, which I have just created, right? There is a version 1, and yeah, there is a source run, and if you want, you can download the model by clicking model and download the model to your computer, right? So, but that's just the MLflow. And as I said, this whole guide is not about MLflow. This guide is about data science stack. But as you can see, the seamless integration between your notebook, your GPU, and your MLflow in action, okay? The next thing I would like to show you, just for the sake of completeness, if I go back to terminals, I was now connected to the first notebook server, Jupyter Lab server. I can now connect to the second Jupyter Lab server, which is the TensorFlow CUDA Notebook 2. That's a different URL. As you can see, it's 153. This is 214. This was 153. Yeah. And now I can connect to the second one. And everything is shared in the shared. So there is a folder. And I have created also a second notebook, which is the TensorFlow NIST Predict. And inside this NIST, again, you need to install MLflow. So that will take a couple of seconds. But inside this notebook, what we are doing is that we are loading the model with MLflow load model with the model name NIST TensorFlow model. That's the name which we used for logging, right? And basically, I'm just showing you that from the other model, other notebook, I can connect to MLflow. I can download the model and I can run inference, right? So I'm downloading the model. I'm getting the dataset, normalizing the dataset because when you're using models, the data needs to be in the same format. And then I'm running some predictions and I'm outputting some predictions and what were the actual classes. So I'm importing and now I am running this one. And as you can see, downloading the artifact, this will download the model. And if I scroll down, this is running predictions on this and there are some predicted classes and actual classes. So I was able to demonstrate you right now that I can download the model, which I stored in MLflow, and then I can run inference directly from inside the data science stack. This is really powerful because now you can play around, right? What you can actually do is now you can create another notebook, this time, for example, with PyTorch, and you can run the PyTorch inference, right? Those are separate environments. Things are installed separately in different images. So all your dependencies are not shared. You can use the MLflow to track different experiments. For example, when I was at the university and I was doing my thesis, I was doing research and I had to run a couple of different models with different frameworks. Right, at that time, it was quite hard to maintain all the dependencies. Right now, you can create a couple of notebooks with different frameworks. You can run the training of different notebooks, and then at the end, you can just compare them by looking into the experiment section in the MLflow, right, and compare the metrics, right? Or you can create some nice visualizations in another notebook where you have another dependency, which is used just for plotting or visualization. Okay, so all the things what I was explaining here are documented in our documentation section, and the example repository is here. I can encourage you to check it out. And the things at the end, which I would like to also show you, is the rest of the commands. So if we go help, what you can actually do is you can remove the notebook with DSS remove, right? So I can go like DSS remove and say, okay, remove this one. I will close it, right? You can stop it, right? But you can remove this one. This will remove the notebook, right? So if I now run the DSS list, you will see the notebook has been removed. You can stop this notebook and later start it, right? So if there is some long-running process, you are not consuming too much of the resources. But some of you may be asking, okay, how do I remove it? Because you are running on top of your Kubernetes deployment, micro-K8s deployment in this case, in your computer, and maybe you want to use the micro-K8s for something else. It's not a problem. You can remove the DSS as simple as running command DSS purge. So this is DSS purge, and this will remove the DSS completely from your micro-K8s deployment, right? So there are no more resources. It will release all the resources. You will not have problems. And the last thing what you want to know is if you want to remove the data science stack snap, you can run the command sudo snap remove data science stack and purge, which will remove the data science stack completely with everything what was installed there, right? So again, the thing what I'm not demonstrating here today is the capability of using Intel GPUs. Data science stack now also supports the Intel GPU vendor. Besides the dedicated graphics card from Intel, we are also able to support integrated graphics card with frameworks like OpenVivo and IPEX notebooks. So I highly recommend you checking out this documentation and playing on your own. The thing what I love about the data science stack tool is that you can use these different kinds of GPUs and everything is just set up for you, so you don't need to worry about drivers on different levels and stuff like this, okay? But this was the demo. The data science stack has been removed. I can remove the snap, right? And we can go back to our presentation. And there is one more last slide, which is just summarizing what are the benefits of the data science stack. As we have seen, data science stack is really easy to get started for beginners. You basically just need 3 commands. If you're running on top of Ubuntu or Snap-based system, right, you can install the microcades, you can install the data science stack, you can connect them together, and you can just start playing around. You can just start developing. When we say beginners, this tool is also important for the data scientists in enterprise companies, which who needs to play around with different experiments daily. They need to try different setups of parameters, different setups of frameworks, right? So data science stack give you this option to run it locally in your machine if you have GPU. The best part is if you don't have GPU, you can run these by running just the simple images, the TensorFlow without CUDA, right? That will allow you to run these experiments on the devices without GPUs, right? So then the development can be really sped up because you can play around with simple ideas, and then when you have something, you go to a machine with a GPU and you start working with it. Secure ML environment because it's a snap, it's a self-contained, it's scanned. Our CI is checking for vulnerabilities, and we are working on fixing those if there are some. It's scaled with the same tooling, right? So it has a lot of open source tools inside. You can use tools like MLflow. We are providing you different images which we are testing it with, and it's easy to upskill and fully open source solution. So that was my demonstration. Just want to tell you, if you are searching for something more advanced, like for deployment with inside the Kubernetes cluster with multiple hosts, you should check out our Charm Kubeflow offering online, which helps you to run this at bigger scale. But data science stack is here for you. Thanks for watching. Thanks for listening. And if you want, you can reach out for me on my social media, and you can check out the source code on my Git repository. Thank you again. Hope I see you again.